My name is Fanis Prodromou. I'm a Google developer expert in Angular, author of the book Mastering Angular Reactive Forms. I'm an educator and technical content creator, senior Angular developer at the company ASI, and co-organizer of the Angular Athens meetup. Now, today's topic is about atomic state strategies for complex Angular UIs. Perhaps you might already have something in mind in terms of complex Angular UI, all right, and you know what state strategies are. But how about the atomic part? What are the atomic state strategies? And this is what I plan to do today. I plan to explain to you a very nice pattern. But at first, I have a rhetorical question, and this is the one. Where does state live? Let's assume that we have this very nice page, where what we have is no more like the URL, then we have the logo, and we have the menu with products, stores, and favorites, and this kind of very small counter, a badge counter with a number 6, and then we have a list of product cards. So let's now try to see where state live. So we have this very small one, which is just the counter 6. And this one is considered to be global state. I know that someone might be like, no, this is definitely not a global state. This is something, a very small one. We shouldn't consider that global. However, conceptually, it is global state. Why? Because we need to have that horizontally into our application. Think the following. Think that we have one of the verticals could be products, stores, and favorites. And no matter in which page we are, either products or stores or favorites, this badge, this counter should always be there, visible to the user. That's why this is considered to be a global state. Then we have this the component state, which is part of the product card, and it is no more like a set of variables that determine what the UI looks like and how it behaves at that specific moment. And then, of course, we have the URL, which is the highest level of state. And the URL dictates that we are on the products page or on the stores page or on the favorites page. And perhaps we can provide there more query parameters based on the number of pages, filters, and stuff like that. So where does state live? We talked about the global state, which is the horizontal state of the application, the component, which is the information of that particular component, and then we have the URL state, which is the highest level of state. Nice. But you know what? And perhaps there are many other categories, but I don't want to dive deep into this one. But what I would like here to highlight is the following. Whenever we are talking about and we are reading perhaps a book about a technical part and the theory, things seems a bit easy, right? You understand that, you know how it is and how it works, but then you have to move the theory part into the real code. And this is where things got a bit more complex. And that's why I have prepared this small application where I have the name Green Heaven. And this is the application that I'm using also for my workshop. And honestly, don't ask me why I decided to have it like Green Heaven, but anyways, this is it. So what this is, so we have the logo, we have the menu where we have the home, catalog, then we have the favorites heart, icon, the basket, and on the left side, we have some filters, and on the right side, we have some results, okay? And we will try now to work with this page. But at first, let's go into the left side, where we have some filters, and see the following. We have 3 different filter categories. One of them are the lighting requirements, where we have 3 checkbox items. Then we have one more, the plant properties, which is a drop-down, and then we have plant type, okay, which is just no more like a radio button. So we have 3 different filter types. What I would like now to do is the following. We would like to establish a communication between the left side, which is the filters part, and on the right side, where we have the results. How can we do that? Well, one option is just to have an output event from the filters component, and then to have an event handler on the results component. and the output handler will eventually grab just the selected filters and do something. If we see the sequence diagram, perhaps this is what it would look like. The actors here are the following: filters, results, and HTTP. So if we follow the approach that we have just described, what we're saying is that the filters will emit the filters, the selected filters, into the results, and the results eventually will invoke the HTTP call. We'll make the HTTP call so that we can have back our results. Nice. This works. This works just nice. However, there are a set of disadvantages. User is lacking the refresh page functionality. If we refresh the page, we will start from the beginning. And someone might be like, and why do we even have to refresh the page? This is a single page application. We don't have to refresh the page. Yes, we know that because we are developers, but the users don't know that. And the users really like to refresh the page. On the other hand, we are missing also the deep linking where the users are unable to share or bookmark a page. We have broken back button. At the time that we are selecting any filter, changing a pagination, it's very nice to also utilize the back button, which is an amazing browser functionality. And also, we are increasing, or to say it better, we have a tight coupling between results and the filters component. So since we have this kind of disadvantages, let's try now to make this flow a bit better, okay? So the actors now are the following. We have filters, we have results, we have URL, and we have the HTTP. And the filters will do the same thing. We'll emit the selected filters. We're doing that into the results, and then the results, we grab those filters, prepare the URL parameters, navigate with those parameters, and then what we have to do is just to read the parameters. We are reading the params and we are making the actual HTTP call. I know that someone will be like, you know what, this kind of step, prepare URL params and navigate, shouldn't be part of the results, should be part of the container. I know, but the idea is still the same. The idea here is that we want to invoke the HTTP call based on the URL parameters. If we follow this approach, the advantages, and actually are the items that we had previously, the disadvantages, I just convert them to advantages. We can now refresh the page. We have deep linking functionality, and the back button works as expected. Nice. And what we're talking about here is that we would like to have the URL as a single source of truth. So this is what we would like to follow in terms of flow. And when I'm saying that the URL should be the single source of truth, I'm saying the following, that based on the URL, we should dictate the selected filters, and we should also dictate the pills that we would like to display there. And for this talk, I'm using pills and chips interchangeable, but it's I mean the same thing. All right. So this is the flow that we would like to follow. Now, we will do together something, the following part. I would like to see what is the code that we will follow, that we will code without having the atomic state controllers. So we will see the before, and then we will see the after part, okay? So let's go now and jump directly how we can implement this kind of functionality that we have just described. First and foremost, we need to have a filters component. And into the filters component, let's say that we'll have a form group. This could be also signal forms, but this is another part of the story. We'll have the filter form, where we'll have the filter 1, filter 2, and filter 3. And if you remember, what we said is that the time that we are selecting any filter, we would like to emit an event. And for that reason, we can have the filter form, value changes, just to have a subscription there, just a listener, listen to the value changes, and map the form values and eventually emit the event. Nice. But wait a minute. What we also said is that when we reload the page, we have to populate the filters. We have actually to grab the URL parameters. We have to map those parameters to specific filter values, eventually prepare the form value so that we can then set this kind of form value into our form, which is nothing that fancy at this point, right? So the only thing that we're doing is we're just grabbing the values, preparing the form value, and we are set it back to our form. Nice, and things will work so far. So let's continue. And one of the things that perhaps we forgot to mention, I forgot to mention previously, is that we have this small button, clear all filters. So what are the requirements for this one? The requirements are the following, that we have to display or we have to enable the button whenever we have any filter selected. If I have this kind of filter selected, this button should be enabled, or this one, or this one. So how can we achieve that now? But since we are in signals, things will be a bit more easier. Meaning, again, under the filters component, we can have no more like a computed property. And for the computed property, we can grab the form values. We can now ignore how we are preparing the form values. Okay, let's assume that we have a function there that is preparing the form values for us. We are grabbing the form values, and if we do not have anything there, we just return false for the has active filters, all right? But then if eventually I have any form value, I will create a Boolean expression for filter 1, Boolean expression for filter 2, filter 3, and eventually I will return this one. All right, and this will make the button active or inactive, enabled or disabled. Okay, but at the same time, we have also this kind of thing, which are the pills. All right, so let's jump now in another component and talk about how eventually we can construct the pills. So currently we are under the pills component. Don't try to read the code. This is more like a pseudocode. You have already understand that this is not code that works. It's more like just to explain some parts. So into the pills component, what we're doing is that we can grab the query parameters. We can map those URL values to a model so that we can interact with the actual URL. And eventually, since we have signals, what we can do is to create a computed property for our chips, for our pills. And how can we eventually do that? Well, it's not that hard. What we have to do is to loop over the selected checkbox items. And we have to loop over because for the checkbox items, we expect to have more than one item selected. So we are just pushing a new item with the key and the label into the result. And then we're doing the same thing for the single select items, either this is a radio or select menu, and eventually we just return the result. So as you can see, for all of that steps, they are not that hard, but they are many and in different places. So let's now, and this is only to display the pills. I didn't explain the code that we have to write of what will happen when we are eventually removing a pill. So let's now create a list. What are the steps that we need to have for every filter? Let's assume now that we're going to introduce a new filter. So what are the steps? Well, we have to add a new form control to filter form, all right? We have to update the template with the filter component including the form control name, just the binding there, okay? We have to update the emit filter state method to serialize the new filter. We also have to populate the form URL to populate the actual URL parameters. We have to update the clear filters to reset the new filter. We don't have to forget that. We have to update the has active filters computed to know that, oh, you know what, I have a new filter and I have to update this kind of functionality. I have to update the pills component to display the new filter chip. I know it's a bit big list. And I also have to update the pills component again to have the functionality on what should happen when we are removing the chip. Okay. So we know that these are the steps that we have to follow. And to me, it seems like that we have a single unit, which is a filter, and that filter has certain logic and functionality, and we scatter that around. So instead of keep that a bit more isolated, a bit more focused, we have pills component, different methods filters component, different methods, perhaps into the results functionality, different methods, different functionality. So for every single filter, we are doing this again and again. And now let's see the after part. The after part with atomic state controllers. Currently, we have seen the before part and how conceptually this should work. And now let's see how we can do that with atomic state controllers. But first and foremost, what is a controller? Well, let's go to the MVC design pattern. If we go to the MVC design pattern, and we can see the following, that the M, the model, answered the question on what the data is. Okay, how about view? The view is what the user sees. And then we have the controller, which is the brain that coordinates the model and the view. Wait a minute. If we focus a bit now into the controller part, is the brain that coordinates model and view. I think that this one is very close into the component state that we saw previously. This is what we have to do. We have to coordinate the model and the view and prepare something for my component. All right. So let's now again do like we said at the beginning, at the very, very, very beginning in the intro. Let's have a pen and paper exercise. And before even we start coding for the atomic state controllers, I would like to have just a pen and paper exercise and gather the filter requirements. Okay? So this is what we have. This is the page. And let's now focus into one specific filter. Let's focus just into this guy right here. All right, so what do we need to have? At first, to make that happen, to have the filter, we need definitely to have a list of options. List of options meaning that we need to have the options that we have to iterate over and display the checkbox items, semi-shade, shade, or sun. Okay. Then we need to have the selected values. Eventually, we need to know, do I have semi-shade selected, or shade, or sun? Someone needs to provide this information. And I also need to have a flag for the hash filter, if I have eventually anything selected or not. And how about now if we add into this exercise, into this small paper, the pills as well. So we can know now that if I select anything from here, I need to have this kind of pills. All right, so this is all under our data. The data that we need to have for a specific filter. However, this is not the only thing. We don't need to have only data. We also need to have some methods. So let's keep that aside. And now let's focus into the methods part. And when I say methods, I mean that when eventually we select any filter, we need to apply the filter. We need to do something with that one, right? So we can have this method there. And also, what will happen when eventually we clear all filters? We reset the filters. Something should happen. We need to have this method as well. And how about the remove filter? We have, as you can see here, we have the small X icon. And when we click that, we have to remove the filter. And all right, so we have 3 different methods. So let's keep that aside. And it's time now to construct our controller. And the controller is just a fancy name. This is the drum roll, ta-da-da-da, for a function. This is no more like a function that manages some state and behavior. But you know what? This is the amazing part here. Since we now have signals, we can have stateful functions. And we can create a function to behave something like a facade and a closure, something in between, stateful functions with the power of signals. So let's now see what a controller is all about. A controller is something like that. We can have just export function, atomic filter controller, name it however you like. And if you remember into the pen and paper exercise, we said that we need to have data and methods. And for the data, we need to have the options, the selected options, the pills, and the hash filters. And for the methods, we need to have the apply filter, remove filter, and reset filter. And like what I said previously, we can keep state internally into this function. And we can do that just by utilizing the signals. And here we can just keep the selected options to know that, oh, you know what? Whenever I'm grabbing this function, every time I know what kind of options I have there. And not only that, we can also derive the pills using a computed property. We can have the apply filter logic, and we can have also the remove filter logic, that we know that we can do something with this filter whenever we are removing that. And the idea of the atomic filter controllers is that we can inject them whenever we have the injection context. And for that reason, we can also have, we can inject router or any other service that you can have in mind. The idea of this kind of controllers is to increase the reusability. To increase the reusability, we have to make that a bit more reusable, I would dare to say. And to make them reusable, a function, how can we have a function more reusable? Of course, by providing some arguments. And here, the arguments could be, for example, the options. If you remember previously, what we said is that we need to have a specific set of items that we have to loop over. So we can provide this kind of options. And not only that, we can also have an apply filter hook. Whenever we are applying a filter, I want to invoke the apply filter hook so that I can do something with that. All right, but how can I use this now? Well, to use this, we can start constructing that. So let's do the following. I have here the filters component, where let's name that plant type equals atomic filter controller, where we can provide just a controller name, just a unique ID, no more than that. And then for my options, I can have a signal of indoor and outdoor, for example. And I can also provide the selected value. And here I have the selected value because this one, and not plural, I mean, because this one accepts only once, since this is a radio button. And I can grab the plant type from the URL params. The URL params here is out of this topic. Let's assume that we have somehow a way to grab the URL parameters in a nice and a clean way. And then I would like to have some methods. This is what we said previously, right? And as you can see here, my method is apply filter hook. What I would like to do is, whenever we are applying this one, I would like to navigate using query params, plant type, utilizing the value that will be provided into my apply filter hook. And you know what? For that specific filter, I want also to track an event just for my analytics. And of course, we can provide more methods like reset filter hook or remove filter hook. And this is just the configuration. This is all we have to do just to create one specific filter. It's just a filter for this use case, but of course, we can do for many other use cases. A set of configuration just to have everything tied together. And now, how about using that into the HTML? So how can I do that? Well, before, we had something like that. Into the radio filter, we had to provide the options, we had to provide the selected values, and we had also to have some outputs, the filter change, filter reset, and filter remove. But now, what we have is the up radio filter by providing a controller. The components should know that they have to work specifically with a specific controller. And the components know that if I want to interact, I will interact directly with my controller, which acts as a bridge. And if I want to add more components, I can do that, because this is what the controller is all about here. We can reuse that. We have the same component, but different behavior. And here we have the plant type, we have another filter type, one more filter type, whatever. And each controller here has different options, highly configurable, different selected values, different side effects, and we can just have different things. And I know that this is a new mental model, and I know that currently we're talking about filters. Filters here, filter there, but what I'm saying is that we can use for any other use case that you might have in mind. So, for example, let's see a bit more totally abstract thing. Let's assume that for our place, we would like to have just a remote controller to have the same functionality just for handling the remote controllers of my for my house. My device ID could be living room TV, and I would like to provide some channels: HBO, Netflix, YouTube. Yeah, I will remove YouTube. Doesn't make sense to have HBO and Netflix. And then for the current channel, I decide to pick that one from a service that comes from somewhere. I don't care. And I have some methods as well. What will happen when I change channel? What is happening when I'm turning off my TV completely? All right, so this is a bit more abstract. So let's now go back again to our example. Currently, let's assume the following, that we have already prepared 3 different controllers. We have the light requirements controller, we have the plant properties controller, and we have the plant type controller. We have everything there nice and tidy, and we can start using them. And every controller has different configuration, and we can start using them. All right, but wait a minute. We have this button here, the clear all filters. And the functionality for this one is the following, just to refresh our memories. We have to enable that whenever we have any filter selected. So how can we have that now? The good news is that we are exposing signals, and we can definitely use a computed property for this one, just a computed property for the light requirements for plant properties and plant type. But how about if I have 50 filters? Do I have to do that 50 times? And the same thing is happening here. Again, for this one, what we have to do is to use a computed property just to accumulate the selected item, the selected filters from every selected item here. But again, what will happen if we have 50 of them? Do we have to do that manually? Well, I really like the idea of having the computed property, but I really don't like the idea of doing that manually. I prefer to do that more, let's say, automatically. So let's now see the following, that we have the controller 1, that controller 2, controller 3, controller X, controller whatever, and every one of them, they have data and methods. So what we can do is to introduce one more controller here, which is our wrapper controller that can accumulate the data from every individual controller. And the wrapper here is very useful because it speaks to all using the exact same interface. So currently we had only 3 controllers. Now we are introducing a fourth one, a fourth function. And how can we use, where are we going to use this kind of function? We will use that for our nice pills, and we will use that also for this kind of button. But wait a minute. We're saying that we have to create a new controller. And if you remember at the beginning what we did, a pen and paper exercise. Let's do this pen and paper exercise here as well. For the wrapper controller, we need to have just the data for the hash filters flag whenever we're going to have that enabled or disabled. And we need to have also the pills. All right, let's keep that aside. And let's do now the pen and paper exercise for the methods. And you know what? For now, we will keep that a bit lean. And the only one method that we're going to have is the reset filter. When we clear all filters, we're going to do something. All right, so let's keep that aside and let's jump directly to the code and start coding that. Again, no more like a function, atomic wrapper controller, and we return data and methods. What kind of data? Pills and hash filters. And what kind of methods? Just the reset filter. Nice. But here, we need to have one more special method, and this is the register. We need to have the register method since we need to introduce to the atomic wrapper controller the individual controllers. Somehow, everyone, the wrapper controller needs to know the other filter controllers as well. And we'll keep this information internally into a controllers array. And now let's go into the implementation part. What we said is that we need for the pills to have a computed property, right? And here it is. We do have the computed property, but this time we don't have to do that manually. We are relying solely on the wrapper controller to do that for us. We have just to reduce over the controllers, and then we can accumulate all the pills. And the same thing is happening with the result filter. We are looping over the controllers, and we are just invoking the method that every individual controller has attached to. But now, how can I use this information? How can I use that? Well, let's see that. Again, under the filters component, what we are doing is that we are creating an instance of the atomic wrapper controller. Here it is. We have the wrapper controller, and we have to introduce, if you remember previously, we have to introduce the wrapper controller into the atomic filter controller, and internally, it will just use the register method. And let's assume that we have everything configured properly into my filters component. But eventually, how can I use that to make use the power of the wrapper controller? Well, when we clear all filters, I don't have to do any manual stuff that we had previously into the before part. I don't have to clear any form. We no longer need to have a form here. The only thing that we have is the URL as a single source of truth. So when we are clearing the filters, the only thing that I have to do from my filters component is just wrapper controller methods remove filter. No more than that. I don't have to do something else. And I don't care how this will work, meaning from the wrapper controller. Every individual controller knows the functionality that needs to be implemented. And how about the pills? If you remember, this was the code that we used to have previously, where we had to read the query parameters, to do this kind of mapping, and then eventually to have a computed property to loop over the filters. And here, the thing that I don't like it that much is that, you know what, from the pills component, I need to know, and I need to find a clever way to display eventually the correct label. But I don't feel that this is a responsibility of that component. I would prefer every individual item to know about his responsibility. So instead of having this one, now we can just replace that with this thing, this wrapper controller data pills, and we'll have everything for my pills just to display that there. So for every filter, and this will be my last slide, what we're doing is that we inject the appropriate atomic filter controller because they are highly reusable. We just have to configure it, no more like that, and add the atomic filter component to the template wired to the new controller. And in summary, what we are achieving with this kind of pattern, it's highly maintainable. Whenever we have a bug, we don't have to go into the results page component and risking on breaking the results functionality, the search functionality. It's highly maintainable because they are isolated. Reusability, highly reusable because they are configurable. Single responsibility, by all means. Atomic coordination, we have the wrapper controller. We don't have to do something manually. We rely solely on the wrapper controller doing the job for us. Reduce cognitive load. Well, this is so-so. Why? At first, this is a new mental model, and we need to understand how this works. We need to have our hands dirty. And as soon as we have that, then indeed we have reduced cognitive load. But at the beginning, we need to learn how this works. And also, this is a great way also for newcomers into our team. And the reason is that they know that, you know what, I have to deal with the same thing, the same functionality, isolated for every complex UI part. So that was all from my side. Thank you very much for your time and your attention.
As always, great talk, Fanis. We've learned a lot of new things, and it's interesting that you're bringing up the topic of MVC, as it was like kind of old pattern, but I see very good use case for it right now in the modern Angular.
Yeah, indeed, and it seems that we can have this kind of thing just to grab the concepts. And if we grab the concepts, we know how we can utilize this kind of concepts. All patterns, but still they are used. And if we understand deeply how this kind of patterns work, we can make it better for our use cases.
Yes, definitely. And I like the reusability of this solution. It's like super cool. Okay, I see we have a few questions in the chat. So let's start with the one from the Natalia. Is atomic state with signals an evolution of Angular itself, or rather an attempt to adapt Angular to the fine-grained reactivity trend?
Good question. No, it's not an evolution. The atomic state if it's an evolution of signals of Angular itself. No, it's not an evolution of Angular itself. But what I would like to think of is the following: that I have been using Angular since Angular 2, Angular version 2. And back in the days, it was solely object-oriented. We had a class for everything, right? But now what we have is mainly a more functional approach. We have functions for guards, we have functions for resolvers, we have functions for almost everything. So this is not an evolution of Angular itself, but it's more or less like following this kind of trajectory of Angular.
Yes. Okay. As far as I can see, this was the last question. You can wait for like 20 seconds. See if somebody else also have a question.
And I will share the code. I know that whenever we have a new mental model, we need to have our hands dirty. So I will share the code into the YouTube channel just for people to can follow along. Whenever we have something new, you need to truly understand how this works. To, like what I said, to have your hands dirty and realize, oh, you know what? I like it, I hate it. And then perhaps, now that I use that, perhaps I have 50 more questions on how we can do that even better.
Yes, I agree. You can't learn something without trying. It's like the whole point of the learning. You have to first fail, then understand what you did wrong, and finally you can learn something.
Exactly. And it's also very good, this one, it's also very good for unit testing. Since this is no more like a function, it's very easy to unit test that. But this is not my topic. Eunice will sign on his next talk on this one.
Yes, we'll wrap our Q&A session. I don't see any more comments in the chat. So, Fanis, once again, thank you for joining us today. This was a super great talk, and I haven't seen this pattern before. So, nice job on this experiment.
Thank you very much.
Once again.
And thanks for having me. It was a great pleasure. Thank you. Bye-bye.
See you.